Take a look at a construction site here in the United States, and the excavator you see will almost always have one thing in common. One smooth, single piece of high-tensile steel sweeping out from the cab. Rigid, powerful, no pivot in the middle, just a clean, structural arc from the house to the stick. That is a monoboom, sometimes called a straight boom or one-piece boom, and in American mass excavation, it is the default. Now fly to Germany, France, or the Netherlands. Walk up to almost any job site over there and you are going to see something completely different. A boom that bends, a boom that folds, a boom that can actually change its own geometry in the middle of a dig cycle. That is the variable angle boom, the VA boom. Some people call it a two-piece boom or knuckle boom. In technical circles, you will sometimes hear it called a TAB, a triple articulated boom, though that term more accurately describes a three-pivot configuration found on specialized demolition machines. Same machine platform, completely different tool. And if you asked most American contractors why they don't run them, you might hear that a monoboom is just how an excavator is built. But there is a real story behind that choice, and it tells you everything about how the environment you work in dictates the engineering you use. Let's start with the mechanics, because you have to understand what these two booms actually are before you can understand why one dominates each side of the Atlantic. The monoboom is built for one thing: consistent, high-production digging. It is a rigid structure that pivots from the machine's base. Manufacturers like Volvo and Caterpillar position it as the standard for mass excavation. It is simple, it is light relative to its length, and because it carries no articulation joint, it maximizes the machine's rated lift capacity at full horizontal reach. That last point matters more than most people realize. We'll come back to it. The VA boom is a different animal entirely. Instead of one arc, it has two segments connected by a heavy-duty hydraulic joint right in the middle. The operator controls that joint with a foot pedal or a thumb slider, tucking the boom in or stretching it out on demand. That one capability changes everything about what the machine can do. It can dig vertically right up against its own tracks, something a monoboom physically cannot do without the stick slamming into the cab or the undercarriage. It can work under a low bridge or a power line by keeping the elbow of the boom tucked down and out of the way. It can reach into places where a standard boom would hit something before it ever got to work. On paper, that sounds like a slam dunk: more flexibility, more options, more capability in tighter spaces. So why isn't the entire American market using them? The answer starts with the land, and it starts with cycle time. American construction, especially outside the dense urban cores, is built around scale and speed. A Texas highway project, a Georgia subdivision, an industrial park in the middle of the Midwest. When you have space, the number one thing you want from your excavator is not flexibility, it's cycle time. How fast can you load that truck? How many passes per hour? How many tons moved by the end of the shift? That's the math that drives American job sites. The monoboom is optimized for exactly that. Here's the physics. Because the monoboom has no middle joint and no extra hydraulic cylinder, the boom structure itself is lighter than a VA setup. That saved weight is not wasted. It gets converted directly into lifting capacity at reach. When you are swinging out to load a dump truck or set a heavy trench box at full extension, that lighter boom means you can carry more weight in the bucket before the machine tips. More payload per swing, more tons per hour, faster cycle time. A VA boom, by contrast, is heavier. The joint, the extra cylinder, and the reinforced structure around the pivot all add weight to the front end of the machine. That extra weight reduces the rated lift capacity at full extension. The machine is not weaker, the hydraulics are just as powerful, but the physics of the load chart work against you when you're reaching out. For the open, high-production American job site, that trade-off often does not pencil out. Now, there is a nuance here that matters. While the VA boom gives up capacity at maximum radius, it gains significant capacity when working close. With the boom articulated, the operator can pull the load in toward the machine's center of gravity, achieving higher lift ratings than a monoboom can in that same confined geometry. In European urban work, that close-in capacity is exactly what the job demands. In a wide-open subdivision or highway cut, it rarely comes into play.
There's also a labor factor at play that goes beyond the specs. American contractors are reliability-first buyers, yes, but modern VA booms are not inherently unreliable. The extra cylinder and pivot joint are engineered for the duty cycle, and major manufacturers have thousands of these machines running high hours with no more downtime than their monoboom counterparts. The real friction point is operator skill. A VA boom requires training. An experienced operator running a monoboom can load trucks efficiently with minimal learning curve. A VA boom, to achieve the same cycle times, demands that the operator develop muscle memory for the articulation control, usually a foot pedal or thumb roller, and learn to coordinate two boom sections simultaneously. In a high-production environment where labor turns over or where operators rotate across fleet machines, many contractors decide that the training overhead is not worth the flexibility they don't need. That's a business calculation, not a verdict on the hardware. There's also a cultural factor that runs parallel. When you're running a fleet on thin margins, your first question about any piece of equipment is not just what can it do, it's what does it take to keep it running. A monoboom has one hydraulic circuit for the boom, one set of pins and bushings, one cylinder doing one job. If a hose blows, you find it immediately. If a pin wears, any shop in the country can press in a new one. That simplicity has real value. The VA boom adds a second major hydraulic circuit, a second large cylinder, and a high-stress pivot point right in the middle of a structure that's absorbing enormous loads all day long. Are those components robust? Absolutely. But they add complexity to maintenance, parts stocking, and repair diagnosis. For a fleet manager who values standardization across hundreds of machines, that complexity is a genuine cost, not necessarily in breakdown frequency, but in parts commonality, technician training, and service turnaround time. In the American used equipment market, that complexity also hits resale. A standard monoboom machine sells fast and sells well. A VA boom machine is often viewed as a specialty item. It can take longer to find a buyer, and it may command a lower price. For a contractor who is thinking 3 or 4 years ahead to when they refresh the fleet, that matters. Now let's talk about why Europe made the opposite decision. Because it's not that European contractors are smarter or more adventurous, it's that they're working in a completely different environment. In a city like London, Amsterdam, or Paris, you're not working on a 10-acre open lot. You're working in a 15-foot wide alleyway with a 400-year-old building on one side and a live gas main on the other. Overhead utilities, medieval drainage systems, pedestrian traffic 6 feet away. No room to swing, no room to reposition, no room for a long, rigid boom arc to sweep through the air. In that kind of urban canyon, a monoboom is a liability. Its swing arc is too wide. You would spend half your time retracting and repositioning instead of digging. The VA boom lets a 20-ton machine shrink its working footprint down to the point where it can operate in spaces where you would normally have to bring in a much smaller, much less powerful machine. That means you get the big machine's power in a small machine's envelope. In European urban construction, that is not a nice to have. That is how you survive on that job site. Europe also has a love affair with wheeled excavators, machines on rubber tires instead of steel tracks. In Germany and France, you see them everywhere. Operators can drive them legally from one job site to the next without a trailer, which is a massive convenience on the dense European road network. And wheeled excavators almost always come with VA booms. Here's why. Rubber tires are less stable than steel tracks, so a wheeled machine has a lower base lift capacity than a comparable crawler. The VA boom compensates for that by allowing the operator to pull loads in close to the machine's center of gravity, where the lift rating is much higher. You use both hydraulic cylinders working together for close-range lifts, and you get serious capacity without the machine wanting to tip. There's also a practical road travel advantage that registers in both markets, but plays out differently. A VA boom can fold down much more compactly than a monoboom can. In Europe, with low medieval bridges and strict transport regulations, that folding capability is often the difference between driving to the job site and needing a low loader. In the United States, transport matters too, just in a different way. DOT height limits, typically 13 feet 6 inches, mean that a large monoboom excavator often requires boom removal or significant disassembly to travel legally on a lowboy trailer. A VA boom folds down to meet those height restrictions without disassembly. That is a genuine advantage. Many American contractors, however, have built their logistics around lowboy transport and boom removal, so the VA boom's transport benefit has not yet driven widespread adoption. So where does the VA boom show up in America? Because it's here. It's just deployed precisely in the applications where it genuinely earns its place. Urban utility contractors in cities like New York and Chicago use them to work around dense underground infrastructure, digging around live utilities where a monoboom's rigid arc would be a constant problem. On mini excavators, like the CAT 308 and 309, the two-piece boom is becoming a popular option for backyard construction and work in tight residential spaces. In demolition, where you're constantly changing the geometry of the boom to reach into a structure at different heights and angles, the articulated setup is invaluable. And as more American contractors start adopting tiltrotators, the rotating bucket coupler that people call the Swedish wrist, they're increasingly pairing them with VA booms to build the ultimate precision package. The two technologies complement each other. The tilt rotator handles the bucket angle, the VA boom handles the machine geometry, and together they allow a single machine to excavate, grade, and place materials without repositioning. That combination is gaining traction in the U.S. market, city by city, contractor by contractor, as urban construction gets denser and the space to just swing a big monoboom around gets tighter. That combination, VA boom plus tilt rotator, is the direction the industry is heading in precision excavation. Europe is already there. America is starting to follow, particularly in infrastructure, residential infill, and any job where the site is tight and the tolerances are unforgiving. So here's the bottom line. Neither design is better. They're both exactly right for the world they were built to work in. The monoboom is the heavyweight boxer of the American plains, built for reach, built for power, built for the kind of simple endurance that wins on a high production job site where the clock never stops. It maximizes lift capacity at extension, minimizes operator training overhead, and holds its resale value in a market that values standardization. The VA boom is the surgical specialist of the European street, built for flexibility, built for precision, built for the kind of tight, unforgiving spaces where a rigid boom can't even begin to work. It delivers superior close-in lift capacity, folds for transport, and allows a single machine to handle work that would otherwise require downsizing or constant repositioning. And in the U.S. market, the VA boom is no longer a rarity. It's a growing segment, especially in urban infrastructure on wheeled excavators and paired with tilt rotators. The old line that American contractors don't use them is becoming outdated. The more accurate statement is that American contractors deploy them where the math works, in the places where space is tight, precision matters, and the machine has to earn its keep in conditions a monoboom cannot match. Next time you walk past an excavator on a job site, look at the boom. You're not just looking at steel, you're looking at a map of the world that machine was built to shape, and a map of where the industry is heading next. Have you run a VA boom? Do you think the two-piece setup has a future on American job sites as our cities get denser? Drop your experience in the comments, especially if you've run both. That real-world knowledge is worth more than any spec sheet. Hit that like button if this gave you something to think about. Subscribe for more deep dives into the machines and decisions that build America. I'll see you in the next one.